Hello everybody and welcome back to Advanced Maths. Today we're doing something a bit different. We're comparing methods for solving simultaneous equations. So, before we begin, you should know the general methods for solving simultaneous equations. And the two videos I've done this in previously are linked below. We've got solving simultaneous equations and we've also got solving simultaneous equations on graphs. And what I'm going to do today is I'm going to show you 4 different methods of solving simultaneous equations, and we're going to compare them so we really understand the algebra that's going on. So when you are comparing today, think carefully about the methods that I'm using in today's video. Which method do you think is easiest? Are there any shortcuts you could take? Which method would you use in an exam? And I think most importantly is, why is it important for mathematicians to know several different methods for one question? I think that's a really interesting thing, and it is absolutely true. Mathematicians do know lots of different methods for the same question. So, without much further ado, let's look at our question today. Solve the simultaneous equations 2x minus 3y equals 4 and 6x plus 3x plus 6y equals 27. So what we're going to do is going to equate the coefficients. We're going to multiply by 3 and we're going to multiply by 2. And this is giving us 6x minus 9y equals 12, 6x plus 12y equals 54. Okay, now the key here is that we made a 6x and a 6x the same. And because they're the same, we subtract. To cancel them out, we subtract. And when I say the same, I mean they're both positive 6x. So it is positive 6x and positive 6x. They are both positive, they are the same, so we're going to subtract. So we subtract here, 6x minus 6x is 0x. Minus 9y minus positive 12y is minus 21. Be very careful there, of course, because you are subtracting a positive 12y. You have to be careful with your minus signs as ever. And then finally, we've got 12 minus 54 is minus 42. We simplify, we get minus 21y equals minus 42. Divide by the minus 21, and we get y is equal to 2. We are halfway there. We've done the hard part. Now we take one of our equations, doesn't matter which one, and we substitute y is equal to 2 into it. 2x minus 3 times 2 equals 4. 2x minus 6 equals 4. Add 6 to both sides, 2x equals 10. And divide by 2, x is equal to 5. And we have the final answer, x equals 5 and y is 2. Good. That's method 1. Let's look at a similar method for method 2. And here, we're not going to equate the x's, we're going to equate the y's. And so just multiply the top equation by 2, and we get 4x minus 6y equals 8. And on the bottom, we just leave that the same, because the 6y and the 6y can now be cancelled. However, this time it's minus 6y and positive 6y. The signs are different. So here we need to add them together to cancel it out. Before they were the same, now they're different. One's positive, one's negative, they are different, so we're going to add. 4x plus 3x is 7x. Minus 6y plus 6y is 0y. 8 plus 27 is 35. 7x equals 35. Divide by 7. X is equal to 5. We now choose either of our two equations. I'm choosing 3x plus 6y equals 27. Substituting the value we know, x is equal to 5. 3 times 5 is 15. Plus 6y is 27. Take 15 off both sides. 6y is equal to 12. Divide by 6, we've got y is equal to 2. And as before, we've got the final answer. Y is 2, x is 5. Now, of course, in maths, you always get the same answer no matter what method you do, as long as you do the method correctly. And I think that's a really nice thing about mathematics. It just works. So let's compare these two methods. So for the second method, I only had to multiply by 2 on the top equation. The bottom equation I kept the same. And I think that was slightly easier because I only had to multiply one equation. Whereas for the first method, I had to multiply both equations to make it the same thing. And so maybe in exams, you may find it easier to check if there's a shortcut like that you can do. In the first method, we subtracted, but in the second method, we added. And that's just because of us wanting to cancel out the x's or the y's. For the x's, they were both positive, they were both the same, so we subtracted. For the 6y and 6y, we added because they were opposite, -6 and +6. Now the final steps were very, very similar. It was just substituting in the values we knew and then solving it for the other value. Okay, and it didn't matter which equation we chose from the original equations, it's worked. Okay, we've done methods 1 and 2. Now let's look at a third method. So now what I'm going to do is I'm going to divide that equation by 3. I get x plus 2y equals 9. And I'm going to move the 2y to the other side. I'm going to get x equals 9 minus 2y. Because the positive 2y is moved to the other side, it's become negative. I've now got x equals 9 minus 2y. I'm going to substitute it into the other equation. So 2x minus 3y equals 4. I substitute it in like that. And I've replaced the x with 9 minus 2y. And this is clever because just with that algebraic process there, I've managed to replace all the x's with y's. And so my new equation, 2 times 9 minus 2y minus 3y equals 4, that new equation only has y's in it. So we can solve it. And so I'm going to expand the brackets. I'm going to simplify. I'm going to solve it. So I add the 7y to the other side, take 4 off, 14 equals 7y, and divide by 7, I get y is 2. And so now I know that y is 2, and I can use my previous expression, x equals 9 minus 2y, to find x. I substitute y equals 2 into that expression. X is 9 minus 2 times 2, which is 5, y is 2, and x is 5. That's a very clever method as well. It's just substituting an expression for x into one of the other expressions. We're going to do a similar expression, similar method again, but this time I'm going to use the other equation first. So I'm going to add 3y to the other side, and we're going to divide by 2. I get x is equal to 3y plus 4 divided by 2. So I've rearranged the first equation to make x a subject. Now I'm going to substitute that into my other expression, 3x plus 6y equals 27, replacing the x with 3y plus 4. Like this. Now, I have to deal with that equation there, and it's quite difficult. I'm going to multiply out the brackets, 3 times 3y plus 3 times 4. I'm going to multiply everything by 2. Because I've got to divide by 2 in that disgusting fraction, I want to multiply by 2 to get rid of it. Well, the fraction divided by 2 times 2, the times by 2 and divide by 2 cancel out. I get 9y plus 12. 6y times 2 is 12y. 27 times 2 is 54. I really want to draw your attention to 9y plus 12 is divided by 2 times 2 is just 9y plus 12. Okay, 9y plus 12y is 21y plus 12. Take 12 off both sides. 21y is 42. Divide by 12 and 2, 1. Get y is 2. Now, to find the x, I substitute y equals 2 into my equation for x. Remember, x is equal to 3y plus 4 over 2. Like this. Replace the y with 2. 3 times 2 plus 4 divided by 2. 6 plus 4 divided by 2 is 5. And again, as ever, y is 2, x is 5. And so we have 4 different methods for solving these simultaneous equations. Just reflecting on this one, we arranged to make x a subject, but over here we arranged the other equation to make x a subject. I felt the second time was more difficult because we had the expression that was a fraction, where we substituted it into our expression for x into the other equation. This gave us an equation with only y and no x. We then solved it and we got the right answer. Now, finally, just to show you, there is always a check when you do mathematics. We can substitute x is 5 and y is 2 into the two original equations. Like this, like that. And when we figure that out, 2 times 5 minus 3 times 2 is 4. And on the other side, substituting in 5 and 2 and evaluating it, we get 27. Our equations make sense. Our x equals 5 and y is 2 makes sense. I'm convinced this is correct. So my check works, and I'm certain my x is 5 and y is 2 is the correct answer. Okay, so today's video is all about comparing two different equations, four different methods, sorry. And so now you know 4 different ways of solving simultaneous equations. Which way was your favourite? Let me know in the comments below. Which one would you use in the exam? Have you found this useful? Do you think you understand algebra better from watching this video? Let me know in the comments below what your thoughts are. Thanks for watching, and good luck in your exams.